Okay. See, there are three terminologies connected with what? This statement, right? So hope you understood this concept. P tends to Q. What is the meaning of this? If P is Q, P is true, then Q is true. Or I should be more specific. Whenever P is true, Q has to be true. So whenever P is true and Q is not true, then there is a problem. The entire statement will become false. Right? Okay. So I am giving you three things. That is, there is a concept called converse of this particular statement. Right? Have you studied converse of the theorem in your 9th, 10th, 11th, 12th and all? You will have a theorem and there will be something called converse of the theorem. What do you mean by converse of the theorem?
Exact opposite.
Exact opposite. Yeah. If this is true, then that is true. If some A is true, then B is true. What is the converse of that particular statement? If A is true, then B is true. That is a statement. What will be the converse of that particular statement?
If B is true, then A is true.
If B is true, then A is true. That is the converse. So if a particular statement and its converse both are true, then we say if and only if. Right? Necessary and sufficient conditions both will be satisfied. Right? Okay. So converse of a particular statement P tends to Q is nothing but Q tends to P. Right? There is one more concept called inverse of a statement. Inverse means what? So I am saying if P is true, then Q is true. Inverse of that statement means if P is not true, then Q is not true. Inverse is nowhere related with P tends to Q, right? Something different. Contrapositive. When Q is not true, then P is not true. So I'm asking you one question. Among these three statements, one of the statement is exactly the same as P tends to Q. See, you have three statements, right? Right, with respect to P tends to Q. So among these three, converse, inverse and contrapositive, one of them exactly coincides with P tends to Q. Both the meaning are one and the same. Among these three, one of them is another way of saying P tends to Q. What is that?
Inverse.
Inverse. So you do one thing.
Contrapositive.
Contrapositive. Yes. Why?
Because here if it is P is true, then Q has to be true. So in contrapositive, if Q is not true, then P is also not true.
Don't say that. Repeat the thing.
Because
If
the
we are
negation.
looking into the truth table also, it's
truth table shall we do? Okay. So P, Q, true, true, false, false, true, false, true, false. P tends to Q. Q tends to P. You know very well. Q tends to P that here you have false. Other things are true. Then not P tends to not Q. For that you need not P and not Q, right? Not P and not Q. So not P, you know how to write the table. Just not of this. That is false, false, true, true, false, true, false, true. Sorry, not P tends to not Q. Yes. Yes, Pa. What is not P tends to not Q? So Ma, tell me what is not P tends to not Q. So along this particular row alone, it is false, right? All other rows are true. Okay. Not Q tends to not P. Not Q tends to not P now. So along this particular statement, right, the second one, it is false. So which of the two has the same truth values? This one and this one. These two have the same truth values. Can you see? After making the truth table, if you check and if both the truth tables, truth values against each of the row, if they are same for two particular formula, then those two formula are equivalent to each other. So here P tends to Q and not Q tends to not P are equivalent to each other, right? So any other way of convincing this statement? Truth table is one way. So if you could say any other way, that will be happy. Logically, can you argue, give an argument so that this will be satisfied? What do you mean by P tends to Q? Whenever P is true, Q should be true, right? Okay. So what is not Q tends to not P? Whenever Q is not true, then P should not be true. That is the meaning, right? Am I right? Hello?
Yes, ma'am.
Yes,
Yes,
one.
ma'am.
Just think logically about it. I'm asking again and again. I'm not trying to confuse you. I'm just asking you to convince yourself by giving another way of proof for this. Please think about it. I started. 1 minute.
Ma'am.
Not P, not Q. I'll write again clearly. False, 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 true, true, false, true, true. So not Q tends to not P means what? Whenever Q is not true, where here Q is not true, this is also not true, this is also not true. So whenever Q is not true, the only possibility is P is also not true. You already know that this is not true, right? This statement cannot be true because P tends to Q. If that statement needs to be true, now this possibility is not at all there. You know it or not?
Yes, ma'am.
You know this statement, this particular possibility is not at all there, right? Or I should go here better, right? So when you are comparing that, so only possibilities whenever Q is not true, then P is not true.
Ma'am.
So how do you prove this? Just draw the truth tables of both and check. You will find that both the values are same. Biconditional operator, you know, right? So what do you mean by biconditional operator? I told you yesterday. What do you mean by biconditional operator? P biconditional Q means what? P tends to Q is also true and Q tends to P is also true. Right? That is the meaning of biconditional operator. Okay. So that's what this is a old example here. See, Bush wins 2004 election. Bush will be the president for all of 2005. Okay. So when Bush wins 2004 election, automatically he'll be the president of. So what is the president tenure in America? If a person is elected as a president, so what is the tenure there? Just check and see. Tenure for the president in America. How many years he can be the president here? Are you all there?
8 years.
Huh?
8 years.
8 years. Oi. Check and see. 8 years. No. Please check.
Ma'am,
Take your
4 years.
correct. Is it exactly right?
Yes, ma'am.
Yes, ma'am.
4 years.
4 years. Check. Okay. So that's what. So whenever he is elected as president in 2004, automatically this is true, right? He will be the president for 2005. Okay. So if and only if Bush wins the 2004 election, Bush will be president for all of 2005. The other statement will be true. Bush will be president for 2005. Then he has won the 2004 election. Both will be true. If one is true, the other is true. And if you go to the next So if P is true, Q is true, and if Q is true, P is true. Both ways, if you check, it is true. So this statement is biconditional. Can you give me one more example for a biconditional statement? It should be very well convinced. I'll give you. See, if all the sides of a triangle are equal, comma, the triangle is equilateral. If all the sides of a triangle are equal, then the triangle is equilateral. So, whenever the sides of a triangle are equal, then you can very well say that the triangle is equilateral. Similarly, whenever the triangle is equilateral, then all its sides are equal. Both ways it is true. So, these two statements are what? Connected using biconditional operator. So, whenever this is true and this is true, the two statements will be equivalent to each other. Am I right? Hello? Can you give me one more example like this? One more example, yeah. Even you can use isosceles triangle and say, right, if two sides of a triangle are equal, then the triangle is isosceles. If a triangle is isosceles, then two of the sides of the triangle are equal. Correct? Huh?
Yes, ma'am.
Check. Okay, biconditional truth table, yesterday itself we have seen, but anyway, something more they are adding here, right? P biconditional Q means not of P direct sum Q. Okay, I'll ask you one thing. What is P direct sum Q? This operator you have seen somewhere. What is this direct sum? Exclusiva. Exclusiva, right? Okay, so what is P direct sum Q? What will be the truth table for that? Truth values you say for this particular column. Use P and Q and say.
False, true, true, false.
Okay, false. True, true, false. Okay, what will be not of this? Not of this will be true, false, false, true. Exactly same as P biconditional Q. So P biconditional Q is equivalent to not of P direct sum Q. Is it clear? Being the first year, are you all feeling sleepy? Temperature is also very low. Winter season. Hello?
No, ma'am.
No, right? Okay. All together, I think you can see. See, I'll say you something. Not P, I'll give you some time. Not P or Q is equivalent to one of the statements so far we have studied. Can you just think about it and say what is not P or Q equivalent to? Nama, what do you mean by not P or Q? Okay, I'll give you some things. From that you can select and say at least P tends to Q, not P tends to not Q, Q tends to P.
It's equivalent to P tends
Huh?
to Q.
And P tends to Q.
P tends to Q. Okay. So how do you convince?
And the truth table will come out to be same.
From truth table, you are convincing, right? Okay. Any other? Okay, I'll put it not P or Q here. Correct. not P or Q. Okay, not P is there already. So it is true, true, false, true. So same, both are one and the same. So both are equivalent to each other. Any other way of convincing?
I'm like, if P is not true, then that means Q's value will stand alone, like whatever is the value of Q.
Cherry. One more thing here. See, one more way. See, you have to think logically also. See, so here, only for this particular case, P tends to Q become false. Am I right? Only for this particular case, P tends to Q becomes false. Correct? So, not P or Q means what? So, whenever P is not true, Q has to be. What is the meaning of this? Not P or Q, what is the meaning? That way you can look into the logical truth table and you can convince. I have started. See, this P tends to Q is not true whenever P is true and Q is not true. Okay. So what do you mean by not P or Q? Any other way of convincing? Just you can argue by using the truth table. Either P is not true or Q is true. Or even both can be there. Correct? Hello?
Yes, ma'am.
Yes. How do you relate this? I'm asking you. You have to think and say, please. This chapter is very interesting actually. You have to relate both the things. How do you relate this?
P is true, then Q is true.
P is true, then Q is true. Okay. P is true, then Q is true. Just look into this table, yeah. I gave you one idea. See, the meaning of this particular statement is whenever P, either P is not true or Q is true. Since R is there, even both can be true. Okay. And now think about it. So in this statement, any one of the thing is satisfied. The meaning of this is what? Either P is not true or Q is true. So here Q is true. Correct? So this statement is satisfied. And what about here? Exactly. P is not true, Q is true. So that here also it is satisfied. Here this statement. Here what?
P is also not true and Q is also not true.
So will that be satisfied here? How come you say this is clear?
Because that is not P.
That is not?
That is not P.
That is not P. Okay.
Like P is false.
P is false. Yes. Check. Correct. So because P is false, right? Any one thing should be satisfied, right? Either P should be false or Q should be true. At least one of them is satisfied. So that way, if you check, this will not be satisfied only along this particular rule. So the same case prevails in P tends to Q also. That particular statement will not be true only in this particular state. So in that way, if you argue, both the statements are equivalent to each other. Okay. What do you mean by a statement or proposition? It is, we call something as, you know what is a proposition, right? It is a declarative statement which has some truth value, right? So what do you mean by a well-formed formula? Well-formed formula satisfies certain things, right? See, for example, if A is a well-formed formula, not A is also. Examples for well-formed formula are all these things here. you have many prepositions, you can connect them using connectives. Those are called well-formed formula. For example, A intersection B, A or B, A tends to B. All these are well-formed formula. You have many prepositions, you are connecting them using connectives and you are obtaining new formula. So all those new formulae are called well-formed formula. Formulae, right? And one more thing what they are adding is whenever A is a well-formed formula, then not A is also a well-formed formula, right? That's what in general, a string of symbols containing the statement variables, connectives and parentheses is a well-formed formula. If it is obtained by a finitely many number of connectives. Usually we will go for only finitely many number of connectives, not more than that. Okay. Okay, please look into this. What they have given is truth values of P and Q are true. And of R and S is false. Find the truth values of the following. Sorry, okay. So before going into this, you know certain things. What is any formula union true? What is any formula intersection to? Is equivalent to, and then any formula intersection T false. Sorry. Any formula union false. Tell me all the four, then we'll proceed. Any
False is
formula,
true.
any formula union true is what?
True.
True. So this can be compared with A union universal set. Any set union universal set, because truth is like universal set. False is like what? Null set. So any set union universal set is always equal to universal set. So if you compare that, here it will be true. For me, I compare with set, but I think you know very well, right? Okay, what is P intersection T? I can compare this with
P.
A intersection universal set. So whenever you go for intersection, whichever is the smallest will come. So A will come. So it is P. P and false. What is P and false?
False.
False. Because false is the smallest. False is like null set. P is like any set. So A intersection null set is null set. Okay. P are false.
P.
P. So you have to remember all the four formulae. Then we'll evaluate this. Right. So they have given the truth values of P and Q are true. That means you can replace P by true or Q also by true, because P is equivalent to true, Q is equivalent to true, and R is equivalent to false. So now say true or true and false. True and false is like universal set intersection null set. What is universal set intersection null set? Null set. So true and false is false. Okay, what is this equivalent to?
True.
True. Okay. Can you please evaluate the truth value of this? Slowly can you
This
do
is
that?
also true.
That is also true, huh?
Yes, ma'am.
I'll write it here. Yes, okay. True and false, close this, are not of, I think you know, not of false is true, not of true is false. All these things you have to remember. P or Q, true or true, and false or false. Yeah. So that is true and, what is true and false? It is false. Are not of, true or true is true and false. So again, true and false is false, are not of, true and false is false. So it is false or true. So ultimately the value is true. Correct. So please do the third one and say others also.
And
Even
that
if
is
you have
also
come,
true.
hey, keep quiet, 1 minute wait, yeah. Let others. Third one, please do the third one, 1 minute time.
Ma'am, can you please show the question again?
Oh, I'm sorry. Got it?
True, ma'am.
True. Yes. Should I do that or everybody is familiar with this?
It's true.
True.
Yes, ma'am.
Okay. Already one person has completed. No problem. Okay. Next. Write the following statement in symbolic form. So here you are going to learn the first thing, how to write something in symbolic form. We are saying something like this, right? P tends to Q, all these things. These are all called symbolic statements. P is a logical statement and Q is a logical statement, right? See, if either Jerry takes calculus or Ken takes sociology, then Larry will take English, right? So here you can see three different prepositions, simple statements. See, in English you find something called simple statements, then something called compound statement. You know what do you mean by compound statement? You use
Yes,
some kind.
ma'am.
Yes. What do you mean by simple statement? Say,
Two
for example,
statements
tell me.
combined with conjunction words.
Conjunction, disjunction, many things you can use, and you can make compound statements, right? The same way here, these are all simple statements. Jerry takes calculus, Ken takes sociology, Larry will take English. All these statements are simple statements. So what we can do is we can give some notation to that. See, for example, P is Jerry takes calculus, Q, Ken takes sociology, Larry will take English. So what is the given statement now? If either Jerry takes calculus. So what is this statement first of all? Jerry takes calculus or Ken takes sociology. That means P or Q. So if this particular statement, that is Jerry takes calculus or Ken takes sociology, then means this arrow, Larry will take English. That is R. So whenever P or Q is true, then R is true. Is this clear? Is it
Yes,
clear?
yes, ma'am.
Yes, ma'am.
Check. So what about statement, the second one? The crop will be destroyed if there is a flood.
Q tends P.
Q tends to be a check. So So the crop will be destroyed 1 minute if there is a flood. So first P denotes the crop will be destroyed. There is flood. Is this statement correct? There is flood. Or there is a flood. Which should be right? Which is right here? Huh?
There
Should
is
I
a flood.
write? Huh? Nama? Should I write there is a flood or there is flood?
There is a
There
flood.
is. Okay. So mathematics never look into English, so don't worry. Okay. So now go back to the sentence. The crop will be destroyed if there is a flood. So you have to read this sentence in this way. If there is a flood, then the crop will be destroyed. So if there is a flood, then the crop will be destroyed. This way after you look into the sentence carefully and symbolize it accordingly. So this is your B part and this is your A part. Clear?
Ma'am, can you wait, ma'am?
Sure, sure.
Okay, ma'am, thank you.
Sure, ma, sure. Okay, please read these four things. Satisfiable, tautology, contradiction and contingency. And tell me what is the difference or what is the thing you understand, please. Okay, so what do you mean by satisfiable?
It will be true
Satisfiable
at
means
least
what?
once.
Okay, so we need not go to satisfiable first. Tautology means what?
All cases will be true.
All values will be true. See, for example, P is true, false. Not P is false, true. Only one variable is there, so only two rows. So P or not P, if you put, both the values are true. So when do we call something a tautology? If all the, see, there is no row which will have a false value. All the truth values are true. Then we call that as tautology. So P or not P is always a tautology. And similarly, P and not P will always be a contradiction. Contradiction means what? All the truth values will be true. Against each and every row, if you check, the truth value will be false. This cannot be true, right? Okay. In even, not even in one case, it will be true. P tends to Q and all will not be true only under only one case. But whenever you check P and not P, it is always false, right? Okay. So this is tautology. This is contradiction. Then what is satisfiable? Satisfiable means what?
Ma'am,
Contains
just
at least
true that or
truth
false
value
also.
once at least it should have. False also is allowed, right? That is called satisfiable. But you are not supposed to have all the values to be false. That is very important. So in satisfiable, if you look into the, see, whenever a formula is satisfiable, whenever you look into the truth table corresponding to that particular formula, at least one truth value should be true. That means not all the truth values should be false. That is the conclusion we can say. Right? It cannot be a contradiction. At least one value should be true. Cherry, okay. I'll ask you something now. Can a tautology is satisfiable? Can you say that a tautology is satisfiable?
Yes, ma'am.
Yes, mom.
Yes. Is it clear? Then, okay. So, because they said at least one is true, even all may also be true. Right. So, tautology is satisfiable, but satisfiable is need not be a tautology. Right, good. So, what is contingency?
It has a mixture of both truths and
And
false.
false. So, what is the difference between satisfiable and contingency?
Ma'am, in
It
It
satisfiable,
must
doesn't.
have.
all values can be true, but in contingency, that's not the case.
Ah, yes, that is the point. See, in satisfiable, sometimes even all the truth values, satisfiable can become tautology also. If all the truth values are true, but contingency, it cannot be a tautology or it cannot be a contradiction. It should be a mixture. Always, that should be maintained. Right? Okay, correct. Okay. So what do you mean by logical equivalence of two statements? So I think we have seen logical equivalence of statements so far. For example, P tends to Q is logically equivalent to not Q tends to not P. Correct? What do you mean by logically equivalent? Both the truth values are same. If you form the truth table, the truth values are same. And one more statement was also equivalent with that. With this, what is that? You might have noticed that P tends to Q is equivalent to not Q tends to not P, and one more statement.
Not P or Q.
Very good. Not P or Q. All the three statements are equivalent to each other. Right? See, very important. See, whenever two statements A and B are equivalent to each other, then A biconditional B, if you find this value, it will be a tautology. So I am saying this one and this one are equivalent to each other. Right? So whenever I find the biconditional thing between these two things, then it is a tautology. Wait 1 minute. Better, we'll try to understand this. See. P, Q, not P, not Q. I think directly shall I write? You know this, right? Same truth values you'll have. Okay. So P tends to Q, biconditional, not Q tends to not P. Okay, what do you mean by biconditional? Yeah. So A biconditional B. If you find the truth table, where and all you will see false, where and all you will see true. Should I go back? Simply, yeah, P biconditional Q you have seen, right? Where and all you will see true and where and all you will see false.
True, false, false, true.
When both are true and both are false, it is true. If either one of them is true and one of them is false, then in that case, the truth value of that particular statement is false. 1 minute here. I'll go back and show it to you. Can you see here? This one. Both are false. See? It is true. And both are true. It is true. In other cases, it is false. So the same thing if you apply here, Okay. So you have to see, you treat this as A and treat this as some B. Right? Okay. So here both are true. So it should be true. Here both are false. So it should be true. Here also both are true, so it is true. Here also both are true. So there is no such case. One is true, one is false. So this is a tautology. So P conditional Q, biconditional, not Q tends to not P is a tautology. That means then this is equivalent to this one. These two statements are equivalent to each other. So two statements are equivalent to each other. Whenever, if you find the biconditional thing between those two things, and if that turns to be a tautology, then that two statements are equivalent to each other. They are one and the same. They mean one and the same. Clear? What is the time now? Hello?
8:45.
Okay, I'll stop.